I am Jasmine Shija, Assistant Professor of DC Department from Rohini College of Engineering and Technology. Now we can see about computation of DFT using FFT algorithms. Before that, we can see what is meant by computation of DFT and DTFT. The discrete Fourier transforms converts a finite sequence of equally spaced samples of a function into a same length sequence of equally spaced samples of the discrete time Fourier transforms, which is a complex valued function of frequency. And the DFT is said to be a frequency domain representation of the original input signals. Now we can see the DFT path, that is the DFT of x of n. It is given as x of k, which is equal to summation n equal to 0 to n minus 1 x of n e power minus j 2 pi nk divided by capital N, where k varies from 0 to n minus 1. And the IDFT of x of k is given as x of n, which is equal to 1 by n summation k equal to 0 to n minus 1 x of k into e power j 2 pi nk divided by capital N, where n varies from 0 to n minus 1. These two equations are said to be the DFT path. Computation of DFT using FFT algorithm. Here, FFT is a highly effective procedure for computing the DFT of the finite series and requires less number of computations than that of direct evaluation of DFT. Here, this two equation represents the DFT path. Already we have seen this. The two equations are written by using the Tuttle factor. By using the Tuttle factor, we are writing the DFT transformation pair, where the Tuttle factor is given as Wn equal to e power minus j 2 pi by e. And now we want to know what is the need of this need of FFT. First, we can see what is meant by DFT. DFT, it is used to evaluate the endpoint DFT, and in the case of FFT, it is also used to evaluate endpoint DFTs. Here, the DFT, it requires n into n plus 1 complex addition and n square complex multiplication. But in the case of FFT, it requires n into log n base 2 complex additions and n by 2 log n base 2 complex multiplications. Now we can see what is meant by radix to FFT. If the number of output points n can be expressed as a power of 2, that is n equal to 2 power m is an integer, then this algorithm is known as radix to FFT algorithm. Now we can see the advantages of FFT over DFT. FFT is the algorithm used to compute DFT fast, computationally effective than direct computation of DFT, and it is also explore periodical and symmetrical properties of DFT. It makes use of the periodicity and symmetric properties of Tuttle factor Wn power k to reduce the DFT computation time. And the next we can see what is meant by radix to DIT FFT algorithm. In the case of radix to DIT FFT algorithm, it has n point DFTs of a sequence x of n, which converts the time domain n point sequence x of n to a frequency domain n point sequence x of k. And in the case DIT, the x of n is decimated and smaller points of DFTs are performed, and the result of smaller point DFTs are combined to get the result of n point DFT. Here, the n point DFT can be realized from two number of n by 2 point DFT. The n by 2 point DFTs can be realized from two number of n by 4 point DFTs, and so on. Now, in the case of the direct to DIT FFT algorithm, this is the normal order and this is the bit reversal order. Here, the inputs are in the bit reversal order. Bit reversal order means that is nothing but, for example, if you are taking this x of 1, the decimal binary representation is 0, 0, 1. Here, the first LSB is written first. Next 0, next 0. Therefore, it represents that this is 4. Therefore, the bit reversal order of 1 is 4. By using the same procedure only, we are we are just taking the bit reversal order, and here in the case of DIT algorithm, the input is in the bit reversal order. Here, this is the radix to DIT FFT algorithm. Here, first the sequence, that is the sequence is split into even sequence and odd sequence, and also in the first stage we are computing 2 point DFT. Next, this 2 point DFT is computed and form 4 point DFT, and finally we are forming the 8 point DFT, and here the outputs are in the regular order. In the previous slide we know that here we are having 4 Tuttle factor W8 power 0, W8 power 1, W8 power 2 and W8 power 3. Therefore, we are just going to calculate the Tuttle factor by using the same formulas. Next one is radix 2 DIF FFT algorithm. In DIF algorithm, the frequency domain sequence x of k is decimated, and in this algorithm, the n point time domain sequence is converted into 2 number of n by 2 point sequence. Then each n by 2 point sequence is converted into 2 number of n by 4 point sequence, and this process is continued until n by 2 number of 2 point sequence is obtained. And here this is the radix 2 DIF FFT algorithm. Here this is just reverse of DIT algorithm. In the case of DIT algorithm, the inputs are in the bit reversal order and outputs are in the normal order. But in the case of DIF algorithm, the inputs are in the normal order and the outputs are in the bit reversal order. Here this is the butterfly diagram for 8 point radix 2 DIF FFT algorithm. Here first is this 8 computation, next 4 point computation, and last one is 2 point DFTs. Here in this we are this is a general diagram for this DIF FFT algorithm. Here we are representing this is a gender structure, and this is marked by using the Twiddle fraction operation. That's all. Thank you.